Okay, so this is the second part of section 2.2. In section 2.2, this will be your second assignment. And we're still going to be dealing with derivatives. So the first thing, but we're going to start branching out a little bit from what we did. So the first thing we want to talk about is the fact that derivatives like limits are linear operators. Okay, and this is actually kind of nice for a variety of reasons. So let's say we want to take the derivative of x to the fifth plus 6x cubed. Okay, well this looks bad, except that we can break this down into small problems. And we should break this down into small problems. So now we becomes the derivative of x to the fifth minus the derivative of 6x cubed plus the derivative of 5x squared plus the derivative of 3. And each one of these we could do with power rule now. Okay? So let's just do this one first. So you multiply by the coefficient, that's going to give me 5x, then subtract 1 to the fourth, minus, multiply, 18x, subtract 1, squared, plus 5 times 2 is 10, 2 minus 1 is 1, and the derivative of a constant is 0. So there's your derivative. And as you can see, it becomes a lot easier than trying to figure out, okay, how do we do this whole stupid thing? You don't. You do it as parts. And you're doing power rule for each individual little part. Okay. Trigonometry. The derivative of sine of x is cosine of x. Memorize this. You're going to see this over and over again. And the derivative of cosine of x is negative sine of x. Same thing holds true here. You need to know what both of these things are. Let's take a look at how we're actually going to do this. Say I want to find the derivative of that. We say, okay, it looks like that, except I've got multiplied something in here. And you notice that this 3/2 is multiplying it. So the trick here is pull multiplied constants out of your calculus. Which means I want to pull this in front of my ddx. So now it just becomes 3/2 times the derivative with respect to x of cosine of x. Well, this ought to be easy. The derivative of cosine x is negative sine x, and then you multiply that by 3/2. So it's going to be negative 3/2 sine of x. And that's how you do the derivative of these things. Okay, we're going to start with sine and cosine. I'm going to tell you how to get tangent a little later on in the course. But for now, get used to writing and knowing what the derivative of sine and cosine are. The derivative of sine is cosine, the derivative of cosine is negative sine. Okay, Now, they're going to give you a whole bunch of things where you're given a derivative or you're given a function. Then they're going to ask you to rewrite it. And then you've got to differentiate and then simplify. So let's take a look. My function is 3 over 2x. Okay, anytime you see something like this, you have to write this as a rational exponent. So you rewrite this as 3 halves times x, because it's in the denominator, it's a negative, and my implied power was 1. So there is the rewritten with this as a rational exponent. You have to have it in this form in order to use a power rule. Now that we have this, we can use a power rule. So I take the negative 1 and multiply it by that. So that's going to give me a negative 3 halves x. Then I subtract 1 from there. Negative 1 minus 1 is a negative 2. So now we have differentiated it, and we're going to rewrite it back in our old form, which is 3 over 2x squared. Because that negative means that the x squared is in the denominator. And this is how you're going to do these things. Okay. So we find slope of a tangent line at a point. Okay, now the trick here is, if you remember, we're really not finding the slope at a point. We are using 2 points very close together. But you don't tell people who are not in calculus this. What you tell them is that you're finding the slope at 1 point. They think you're a genius or you're doing magic. You don't tell them you're really using 2 points, it's just that they're very close together. So here's how you do this. So let's say we have a function, f of x is negative 1/2 plus 7/5 x cubed. And I want to find the slope of the tangent line at the point 0, negative 1/2. Okay, slope of tangent line. And commit this, know this, equals the derivative. So the first thing we have to do then is find the derivative, f prime of x. You notice I'm using Newtonian, and I have been using Leibniz. Okay, and we talked about this being a linear operator, d dx, and this should be 7/5, by the way. Okay, so now we come in and we take a look at each one. The derivative of a constant is 0. On this one, I multiply my fraction by that, and this is 3 over 1, so you just multiply the numerator. So it's going to be plus 21/5 x, and then I subtract 1 from my power, x squared. That is my derivative. So to find the slope at a point, I need to find the slope, in this case, because we're dealing with the point 0, 1/2, I want to find f prime is 0, which means I plug 0 in for this. So I get 0 plus 21 over 5 times 0 squared, which is 0. Okay, so the last thing then, you do have a derivative key on your inspires. What you want to do is open up a graph window, then you tab to enter a function, press menu, do analyze graph, and pick dy dx. Then you pick a point and it will actually give you the value at that point. Now, I still want to see you do this, but some of the questions are going to ask you to check it with that, and you shouldn't be doing this. On a test, you should still show me all of this work right here.